Okay, on to question number 2. So use the C program to answer the following. First off, A, how many bytes of memory are allocated for all variables in this program? So here we are looking at the code and we're basically finding the region where there are types. So char, int, float, etc. that start that line of code. As soon as we're done seeing types at the beginning of the line, we're done counting the variables. So we've got a char 15. So char is 1 byte times 15 equals 15 bytes for that. And then we've got an int, and an int is another 4 bytes. So 1 int is 4 bytes. So in total, we have 19 bytes for this program. Next up, complete the memory diagram if the program is stopped at line 8 before the for loop runs. Assume no padding, ensure values are in hexadecimal. So we're stopping right here before the for loop has executed. And so we're just trying to fill in these values. The left part's pretty easy. You're just counting in hexadecimal. So we're filling in the next value, BFFFF7FF would be after E and between E and 800, right? So just counting up to fill in that column. In the middle here, we're filling in runner 10 would be between 9 and 11. So nothing too fancy there. And then for the hexadecimal values, we actually need to refer to our ASCII table to see what we're going to put in there. So if we look at the string, we know that we sort of number these 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to fill in the rest of these here so we have it for later. That's what's in our string in memory. So those are the numbers for all of those indices. And so runner at 0 is going to be the W in who. And so we need to find that lowercase w on our ASCII table. And if we pull that up real quick, we can see that that lowercase w is associated with hex 77. And so that's what we're going to put into our memory here is OX77. At the last spot in memory, that 14, we can see that that's actually off the end of this string that we were looking at. And so what comes at the end of the string? Well, that's a null, and a null is OX00. So that's what's in memory there, just knowing that there's a null at the end of every string in memory. And then last part here, what is printed to the screen after the program has completed? This we need to sort of analyze what happens in this loop and understand what's going on. So I'm actually going to do the work up here and then we'll sort of print it out down there. So for this, I would look and see we're doing this loop based on the variable base. So I'm going to set base to 0 and then we're going to check to see what happens. So I'm going to check the condition next. Base not equal to 20. That's true. So we're going to execute the loop. So let's see what happens. We go to runner at base plus 4 and we set that to null. And so we go up into our string here and we say, okay, base plus 4, base is currently 0. So base plus 4 is 4. So we're going to set a null into that position. And then we're going to print %s is on first /n. And we're going to do ampersand runner base, and so base is currently 0, right? Important to note that it's not the plus 4, that didn't change anything there. This is just 0 here. So we're printing from 0, and we're going to print a string, which means we print until we hit a null, which we just inserted one into that string. So we're going to print who is on first. And then we have a /n, so that's not going to be visible, but it's going to go to the next line. So I'll just leave that there to represent what happens. We're then going to repeat our for loop, right? We go back up to the top, and we do base equals base plus 10 when we go back up to the top. So base becomes 10. We're checking our condition again. It's not equal to 20. That's true. So we're going to execute the loop again. We look at what happens. We set base plus 4, which is now 10 plus 4 is 14, to a null. So we put a null there, and then we print %s is on first, and we do that from base 10 now. So we go to 10, which is the first character of when. So we're going to say when, and then we hit the null, so we stop printing, is on first. And then again, /n. So that's our output for part C. Would just be the two printouts there, who is on first and when is on first. So that's it for question 2.